Formula One has seen some of the most jaw-dropping, boundary-pushing innovations in motorsport history. Today we're counting down our top 8 Formula One game-changing engineering hacks that forced the FIA to step in and rewrite the rulebook. These are the moves that made rivals furious and left the grid in awe. And wait until we hit number 1, an innovation so outrageous it was dropped from the grid after just one race. Let's get started. Before we dive into our countdown, let's discuss McLaren's recent controversial front Flexi-Wing, which inspired this list. Introduced at the 2024 Miami Grand Prix, it has sparked a lot of outrage across the paddock. Built using advanced carbon fiber composites, this wing takes full advantage of aerodynamic elasticity, flexing under high-speed loads to reduce drag while maintaining critical downforce in corners. It's a perfect balance for high-speed circuits like Monza. Since Miami, McLaren's lap times have been consistently improving, with both drivers regularly finishing in the top 5. The only exceptions? Spain and Austria, where they still managed to get at least one driver in the top 5. With Red Bull and Ferrari dominating at the front, that's no small feat. According to Article 3.15.5 of the FIA technical regulations, the front wing is only allowed to flex by a maximum of 5mm under a 60N load. This rule is designed to prevent teams from exploiting excessive aerodynamic flex to gain an advantage. So far, McLaren's wing has passed every test, but the FIA is leaving nothing to chance. Since the Belgian Grand Prix, the FIA has been closely monitoring front wing movement using ultra-high-resolution 4K cameras to track dynamic behavior in real time. Their recent statement confirmed that all front wings, including McLaren's, are compliant with the 2024 regulations. However, the FIA will continue to collect data through upcoming races to ensure fairness across different tracks and conditions. This data collection will continue until at least Singapore to build a comprehensive database on Flexi-Wing behavior. With McLaren's straight-line speed improving by up to 10 km/h, the Flexi-Wing has clearly delivered results, propelling them to podiums like their stellar second and third place finish at Monza. But with the FIA keeping a close eye on things, future tests could bring new challenges for this innovative design. Has McLaren found a loophole? Will the FIA crack down, or is this a game changer that all teams will have to imitate to stay competitive? Let us know your thoughts in the comments, and if you're loving this deep dive into F1's most controversial engineering feats, smash that like button, subscribe, and hit the bell for more mind-blowing F1 innovations and drama. Alright, let's get into the meat and potatoes here. Kicking off our countdown at number 8, we have Brawn GP's revolutionary double diffuser from the 2009 season. This innovation changed the game entirely. While most teams were adhering to a more traditional interpretation of the regulations, Brawn found a loophole in Article 3.12.7 of the 2009 FIA regulations, allowing them to create a second airflow channel beneath the car. The double diffuser increased the amount of downforce generated without creating excessive drag, giving Brawn a huge performance edge, especially on high-speed circuits. Other teams like Toyota and Williams also developed similar systems, but Brawn mastered it first, giving them a decisive advantage early in the season. Despite protests from teams like Red Bull and Ferrari, the FIA deemed the double diffuser legal. But by 2011, stricter regulations were introduced to close the loophole. By then, though, Brawn had already secured both the Drivers' and Constructors' Championships in 2009, with Jenson Button taking home the title. The double diffuser is widely considered one of the key reasons Brawn GP dominated the early part of the 2009 season. It was a true example of how clever engineering can turn a midfield team into title contenders. Taking the number 7 spot, we have Red Bull's groundbreaking flexible front wing from the 2021 season. This clever innovation allowed the front wing to flex at high speeds, reducing drag and giving Red Bull a straight line speed advantage that their competitors could only dream of. Sound familiar? Under 2021's FIA regulations, Article 3.8, all aerodynamic components must remain rigidly secured and immobile in relation to the sprung part of the car. While Red Bull's wing passed the FIA's static load tests, it flexed enough at high speeds to minimize drag, giving them a huge performance boost on fast circuits. The ability of the wing to flex under aerodynamic load without breaching the FIA's tests was a masterclass in pushing the limits of the rules. Rival teams, especially Mercedes, cried foul, accusing Red Bull of bending the rules quite literally. The FIA responded mid-season by introducing stricter tests at races like Baku and Paul Ricard, using higher load values and even installing cameras to monitor wing movement in real time. Red Bull had to modify their design, but by the time these changes were enforced, they had already gained a significant advantage. Red Bull's flexible front wing helped them maintain crucial speed on fast circuits, keeping them in the tight 2021 championship battle. This is just another example of how teams push the boundaries of the FIA's regulations to gain even the slightest edge in performance. Number 6 on our list is Ferrari's daring Flexi floor from 2007, a design that flipped the paddock on its head. This is the original aerodynamic elasticity hack, which has somehow inspired teams to reproduce this in other areas of the car. Ferrari had been strong in the years leading up to 2007, finishing second in the Constructors' Championship in 2006, with Michael Schumacher and Felipe Massa securing second and third in the drivers' standings. Despite their strength, Ferrari needed that extra edge to leap ahead, and the Flexi floor gave them the marginal gains they were after. Ferrari's floor stayed rigid during the FIA's static tests, but when they hit the straights at full speed, it flexed just enough to lower the car, slicing through the air with less resistance. It seems flexibility and aeroelasticity exploits are a common thread in this space. According to 2007 FIA regulations, Article 3.15, any aerodynamic part must be rigidly secured, but Ferrari was pushing the limit. The FIA responded quickly, introducing stricter dynamic tests mid-season to assess how parts flexed under race conditions. They capped floor flexibility at 2 mm under high-speed loads, forcing Ferrari to make adjustments. Despite the mid-season crackdown, Ferrari had already reaped the rewards. The Flexi floor proved that critical edge in straight-line speed, helping them to key victories on fast circuits like Monza. It was the final push they needed to secure both the Drivers' and Constructors' Championships in 2007. Flexi floor, Flexi-Wing, what's next? Ferrari wasn't the first and certainly won't be the last to push the boundaries of aeroelasticity in F1. What do you think? Is this just clever engineering or pushing the rules too far? Drop your thoughts in the comments below. And if you're loving this deep dive into F1's most controversial innovations, hit that like button and subscribe so you don't miss any more game-changing insights from the world of motorsport. Coming in at number 5, we've got McLaren's game-changing F-duct from 2010, a piece of innovation that left the rest of the grid scrambling to catch up. The F-duct allowed McLaren to tear through straights with reduced drag, all while maintaining crucial downforce in the corners. This system brought the competition to its knees, and ironically, that's exactly how drivers controlled it, using their knee. McLaren's drivers had the ability to block or unblock a vent inside the cockpit, diverting airflow to the rear wing and disrupting its downforce. This stalling of the rear wing reduced drag and gave McLaren a significant top speed advantage on fast circuits like Monza. Jenson Button's performance at Monza was a prime example, with his F-duct-equipped car achieving superior top speed. Teams like Ferrari, Red Bull and Mercedes were quick to raise concerns, but the FIA approved the system under Article 3.15 of the regulations. Since the driver manually activated it, it didn't count as a movable aerodynamic device. Other teams scrambled to copy McLaren's innovation, with Sauber being the first to implement their own version. However, Ferrari struggled and eventually abandoned the system. The F-duct was a clear game-changer in 2010, helping McLaren boost straight-line speed, especially on power-dependent circuits. While it was practically legal at the time, it was banned the following year due to safety concerns and to limit escalating costs. Despite its brief existence, the F-duct is remembered as one of F1's most innovative aerodynamic hacks, and it even inspired the development of DRS. Number 4. Williams' revolutionary active suspension system from 1992, a piece of engineering that completely changed how F1 cars handled on a track. Williams' FW14B wasn't just fast, it was intelligent, adapting its height, ride and stiffness in real time as if it had a pit crew fine-tuning the car for every corner. Using a combination of hydraulic actuators and onboard sensors, this system collected real-time data on wheel load, cornering forces and track conditions. It allowed the car to lower itself for max downforce on straights and keep optimal grip in corners. Williams was 2 seconds faster than their closest rivals in qualifying laps, an eternity in F1. It was like driving on rails. Nigel Mansell made full use of this system, securing 9 victories in 1992 and shattering records. The FW14B remained stable no matter the forces thrown at it, giving Williams a decisive edge over the competition. But all great innovations have their limits. By 1994, the FIA banned active suspension under the Times Regulations, Article 10.1.2, declaring it too advanced, too expensive, and a threat to the sport's focus on driver skill. Still, Williams' dominance with this system remains one of the most brilliant engineering feats in F1 history. In our number 3 spot, we have Mercedes' revolutionary DAS system. That's dual-axis steering from the 2020 season. This ingenious piece of engineering allowed Mercedes drivers to adjust the toe angle of the front wheels by pushing or pulling the steering wheel. The result? Improved tyre temperature control and handling, giving them a key advantage in both straight-line speed and cornering. Here's the gist of it. The driver could pull the steering wheel towards them on straights to reduce toe-in, helping minimize drag and reduce tyre wear. Then, as they approached corners, they pushed the wheel to restore toe out, giving better grip and turning stability. This allowed them to manage tyre temperature more effectively, especially during key moments like restarts or safety car periods. The system immediately sparked controversy. Rival teams, particularly Red Bull, argued that DAS was effectively a suspension adjustment, which would have been illegal. The 2020 FIA regulations, specifically Article 10.4.2, required that the alignment of the steered wheels must be controlled by a single axis, the traditional left-right rotation of the steering wheel. But here's where Mercedes got clever. DAS didn't interfere with the steering itself, it added a second movement axis to adjust the toe angle, how much the wheels point inward or outward, which helped with tyre management. Mercedes argued this was still within the bounds of steering adjustments. The FIA agreed, allowing DAS to be used for the 2020 season. However, to prevent future systems from becoming too complex or creating an arms race in steering technologies, the FIA clarified that DAS would be banned from 2021 onwards. By then, though, Mercedes had already capitalized on the system's advantages. DAS wasn't just legal, it gave Mercedes a significant edge in controlling tyre degradation and boosting performance on circuits with long straights. It played a key role in Mercedes' dominance during the 2020 season, helping them secure another Constructors' Championship before it was banned the following year. Coming in hot at number 2, we have Lotus's audacious twin chassis design from 1981. Colin Chapman, the mastermind behind some of the most innovative designs in F1, sought to revolutionize the sport with this groundbreaking concept. The Lotus 88 had not one, but 2 chassis. An inner chassis for the driver's comfort and suspension, and an outer chassis dedicated to aerodynamic downforce. The genius of this design was in separating the aerodynamic load from the suspension. The inner chassis, which housed the engine, fuel tank and driver, absorbed the usual road impacts, while the outer chassis handled the downforce, effectively allowing the car to stay glued to the track at high speeds without compromising the driver's ride quality. However, this innovation sparked immediate controversy. When Lotus debuted the car at the 1981 Long Beach Grand Prix, rival teams protested fiercely, claiming it violated FIA regulations. Specifically, Article 3.1.1 stated that all aerodynamic components must be rigidly secured to the car's sprung part. Though it passed scrutineering at first, the Lotus 88 was black flagged after rival protests, and its legality was challenged repeatedly throughout the season. Despite multiple attempts to enter the car in races, including a revised 88B version at the British Grand Prix, Chapman's design was ultimately banned after several protests. Other teams, fearing they'd have to replicate the costly twin chassis design to stay competitive, fought hard against it. It was a huge blow to Lotus and marked a turning point for Chapman, who believed his innovation was misunderstood and unfairly outlawed. Although it never got to compete, the twin chassis remains one of the most innovative and ambitious designs in F1 history. It pushed the boundaries of engineering, proving just how far Colin Chapman was willing to go to gain an advantage in a fiercely competitive sport. And now what we have all been waiting for. Number 1. One of the most outrageous and short-lived innovations in F1 history. The Brabham BT46B, better known as the fan car. Introduced in 1978, this car shocked the paddock with an engineering solution no one saw coming. It was designed to literally suck itself to the track, creating insane levels of downforce through an unconventional method. The BT46B used a massive fan at the back of the car to extract air from beneath it, effectively sucking the car down to the track. This gave the car an unbelievable cornering advantage, with more downforce than any of its competitors could ever dream of achieving with traditional aerodynamics. It was a game changer on the track. According to FIA regulations of the time, Article 3.7, any aerodynamic part had to remain stationary and fixed to the car's sprung mass. However, Brabham's designer Gordon Murray cleverly argued that the fan's primary purpose was cooling the engine, not generating downforce. After tests, the FIA confirmed that over 55% of the airflow was directed toward cooling, making the car technically legal. Despite its legality, teams like Lotus, led by Colin Chapman, were outraged. Chapman rallied other constructors, threatening to boycott the series if Brabham continued using the fan car. Under intense pressure, Bernie Ecclestone, head of the Formula One Constructors Association and owner of Brabham, chose to withdraw the car, not because it was banned, but to avoid damaging relationships and causing a complete fallout among the teams. The BT46B dominated the 1978 Swedish Grand Prix in its one and only race, proving the incredible potential of its design. Though never officially banned, the pressure from rival teams forced it out, marking one of the most debated and innovative moments in F1 history. F1 engineering is all about pushing boundaries, but sometimes those boundaries get pushed too far. From Brabham's fan car to McLaren's Flexi-Wing, these innovations forced the FIA to act, forever changing the sport. But with McLaren's current Flexi-Wing drama still unfolding, we may have another regulation saga on our hands. Now I want to hear from you. Which of these innovations do you think was the most game-changing? Which was the most controversial? Let me know in the comments, and if you've enjoyed this countdown, make sure to subscribe, ring the notification bell, and stick around for more F1 insights and controversies. You won't want to miss what's next.